Good day, grade 9s, and happy greetings to each and every one of you. Welcome to our WorksheetCloud grade 9 Natural Sciences lesson. If you have a question during the lesson, send an email with your question to grade9@worksheetcloud.com. My name is Mrs. Ernston, and I'm the WorksheetCloud grade 9 Natural Sciences teacher. I'd like you to make sure that you have a pen and paper to write with and any important books or notes that you have that go along with this lesson. What's also important is for you to access the worksheet that's associated with this lesson. The work that we're going to cover today is reactions of acids with compounds to form basic solutions. So metal oxides, metal hydroxides, and metal carbonates form basic solutions in water, and this means that they will have pH values above 7. Today's lesson will focus on metal oxides, and we will have a look at how a metal oxide reacts with an acid to form a salt and water. So the general word equation for the reaction is as follows: acid plus a metal oxide, arrow indicating a reaction, gives us a salt and water. So we are going to have a look how metal oxides and metal hydroxides and metal carbonates will all form basic solutions when they are dissolved in water. Do you recognize any of these word equation reactions? We have magnesium plus oxygen reacts to give us magnesium oxide. Iron plus oxygen reacts to give us iron oxide. And copper plus oxygen reacts to give us copper oxide. I would like you to brainstorm everything that comes to mind when you look at these chemical reaction word equations. So make a list of everything that you can think about when you look at these reactions. I would also like you to focus on any similarities that you may see. If you need to pause the video to complete this activity, please do so now. So here we have the periodic table, and we are going to be having a look at metal oxides. So when we have a look at the word oxide, we are having a look at the elements oxygen, which you can see is placed here in the periodic table. And we'll also focus primarily today on magnesium, which you'll see on the periodic table is colored pink, which means it's a non-metal. And we might mention other elements like iron and copper. So the general reaction of metals with oxygen is a metal plus an oxygen reacts to give you a metal oxide. I wonder if you can remember the rules when naming a compound. So we take the metal, magnesium, that is one of the reactants, and we add the elements oxygen. The arrow indicates a chemical reaction. And now we need to label the compound, which is a metal oxide. So in the naming of the compound, you always write the metal first, and that's magnesium. And then the word that comes second, we don't say oxygen, but we say the word ox, and then as a suffix, we use the word "ide." And you will notice in all the chemical reactions where we take a metal plus an oxygen, the name of the metal comes first, oxygen comes second, but we don't use the word oxygen, we add "ide." So iron and oxygen react to give us iron oxide. Copper and oxygen react to give us copper oxide. If we just have a look at the group 1 alkali metals, they are all active elements. They are soft metals with low melting points. They react with oxygen, so we store them under paraffin, but they react very easily with oxygen, and when they do, they form an oxide. Our group 1 metals, and the three that you need to know is lithium, sodium, and potassium, also react aggressively with water to release hydrogen. So the reactiveness increases as we move from the top to the bottom, which means that potassium is more reactive than lithium. So metals in the same group will react in the same way with each other when they react with oxygen. So potassium reacts with oxygen in exactly the same way as sodium reacts with oxygen. So the chemical equations will have similarities. So when we have a look at metal oxides from group 1 on the periodic table, they will have the formula M subscript 2O. In this generalized formula, M represents the metal atom and O represents the oxygen atom. So we can therefore say that metals from group 1 will react with oxygen and have the following general equation, where M represents a group 1 metal. So metal plus oxygen gives us a metal oxide. And remember, oxygen in its elemental form is diatomic, and that is why we write it as O2. So if we take lithium as an example, lithium plus oxygen forms lithium oxide. And this is a balanced equation with 4 molecules of lithium reacting with 1 molecule of oxygen to give us 2 molecules of lithium oxide. So what I would like you to do now is pick any 2 metals from group 1 and write the chemical reaction equation or the chemical formulae using this rule. If you need to pause the video, you can. If we have a look at group 2, which are the alkali earth metals, you need to learn beryllium, magnesium, and calcium. So metals in the same group will react in the same way when they react with oxygen, which means calcium reacts with oxygen in the same way that magnesium reacts with oxygen, which means that the chemical equations will be similar. So when we have a look at metal oxides from group 2 on the periodic table, they will have the formula MO, where M is going to represent the metal atom and O represents the oxygen atom. We can therefore say that metals from group 2 will react with oxygen and have the following general equation, where M represents a group 2 metal. So M plus O2 forms MO. And here we have a balanced equation. So 2 molecules of metal plus oxygen in an elemental form is diatomic, therefore it's O2, reacts and produces 2 molecules of the metal oxide. So if we use magnesium as an example, 2 molecules of magnesium plus 1 molecule of diatomic oxygen will make 2 molecules of magnesium oxide. I would like you now to pick any 2 metals from group 2 and write their chemical reaction equation or their chemical formulae using this rule. You can pause the video if you need more time. So the chemical equation for the reaction between calcium and oxygen is 2 molecules of calcium plus 1 molecule of oxygen forms 2 molecules of calcium oxide. So what is the product in this reaction? So a product is everything that we find to the right of the arrow. And what group are calcium and magnesium from? They are from the group 2 alkali earth metals. Can you write the chemical reaction using pictures, words, and symbols for the reaction taking place in this diagram, with magnesium and oxygen reacting to give us magnesium oxide?
In this experiment, we will investigate the nature of magnesium oxide.
For this we need magnesium oxide obtained from process of burning a magnesium ribbon or strip, a wash glass, water, a dropper, and red and blue litmus paper. Color the ashes from burning of magnesium in a wash glass. This is magnesium oxide. Using the dropper, add a few drops of water to the wash glass and mix to form a uniform solution. Dip the red and blue litmus paper in the solution in the wash glass to ascertain if it is acidic or basic in nature. You will notice that the blue litmus paper remains blue while the red litmus has turned blue. This indicates that magnesium oxide is basic in nature. Magnesium catches fire when heated by a flame reacting with oxygen present in the atmosphere. The result is magnesium oxide, an ash-like substance. Combining magnesium oxide with water gives magnesium hydroxide. The aqueous solution of magnesium hydroxide turns red litmus paper blue, indicating that magnesium oxide is basic in nature.
So metal oxides all form basic solutions when they are dissolved in water. So here we have a table that compares metal oxides and non-metal oxides. So for the benefit of today's lesson, metal plus oxygen gives us a metal oxide. That metal oxide is basic, which means it has a pH greater than 7. And examples of metal oxide is lithium oxide, sodium oxide, magnesium oxide, and calcium oxide. The general equation for the reaction of an acid with a metal oxide is similar to the general equation for the reaction between an acid and a base. which is an acid plus a base, reacts to give us a salt plus water. Since the base in our reaction is a metal oxide, we can just substitute the word metal oxide for base, which means an acid plus a metal oxide reacts to give us a salt and water. And this is the general word equation for the reaction between an acid and a metal oxide. The type of salt that forms will depend on the specific acid and metal oxide which are used in this reaction. If you have the means, the following is a scientific experiment that can be carried out to show the reaction. You will need magnesium oxide powder, some water, universal indicator paper, a white tile or a sheet of white paper, a glass rod or a stirring skewer or a plastic straw, a test tube, dropper, and some hydrochloric acid. If you are able to carry out this investigation, you will need to prepare strips of universal indicator paper. 5 should be sufficient, but you may need more depending on the experiment. And you will put the indicator paper in a column on a white tile or on a sheet of paper. Then you're going to take a very small quantity of magnesium oxide and place it in a test tube. By a small quantity, we mean about the size of a match head. Next, you are going to add approximately 2 ml of tap water to dissolve most of the magnesium oxide. You can use a glass rod or a plastic straw or a wooden skewer to stir the solution until the magnesium oxide is dissolved. This is now going to be called your test solution. Transfer 1 drop of the test solution to the first universal indicator paper, and then compare the color of the indicator paper to the color guide available for the pH. It is important to record this pH before you continue with the experiment. So based on our previous knowledge, we would expect this pH to be in the region of 8 to 14, or it should be alkali because we have taken a metal oxide and we've mixed it with water. Now we're going to start to see what happens when you start to add hydrochloric acid. So add approximately 10 drops of hydrochloric acid to the test solution. Stir it gently and then transfer another drop onto a fresh strip of universal indicator paper. Then read the pH using the color guide and record that in your table. And you will continue to repeat steps 3 and 4 until the pH of the test solution drops below 7. So we would expect to see that we've got an acid reacting with a metal oxide, and we are making a salt and a water. This is an acid-base exchange reaction. So here's the word equation. Hydrochloric acid plus magnesium oxide gives us magnesium chloride and water. The generalized equation is an acid plus a metal oxide reacts to give us salt and water. So because of the acid used and because of the metal oxide used, the salt that we use, or the salt that's produced in this reaction, is magnesium chloride. So this picture here represents an exchange reaction. So initially we have a penguin with a hat on that reacts with a pig with spectacles. The reaction happens, and in this exchange reaction, the penguin exchanges the hat for the glasses, and the pig exchanges the spectacles or the glasses for the hat. So if we represent the penguin with the letter A, we have A as a reactant and we have A as a product. And if we represent the pig with letter C, we have C as a reactant and C as a product. And what happens in this reaction is they exchange some of the elements in the compound. So, hydrochloric acid, the H will represent the penguin. So the H lands up being converted into water as a product. The chlorine in hydrochloric acid lands up being exchanged and makes a salt in magnesium chloride. The magnesium, that is the metal, in this case the pig, lands up going to make the salt. And the oxygen, in this case that's D, or the spectacles, lands up being added to the water. So this acid-base reaction, or acid metal oxide reaction, is an example of an exchange reaction. So to summarize, the acid contributes an H towards making a water molecule. The base contributes an O or an OH towards making the water molecule. And then whatever is left over of the acid and the base after making the water molecule combines to form a salt. Then when we have a look at chemical reactions, it is very important that we also remember how to balance a chemical reaction. So the first thing with a chemical reaction is this arrow represents that a reaction has happened. Everything to the left of the arrow is reactants. Everything to the right of the arrow is products. So in this example of hydrogen reacting with oxygen to form water, hydrogen and oxygen are the reactants and water is a product. When we have to balance a chemical reaction, we can only look at changing the coefficients, which is the number of molecules, and that we find as a coefficient in front of the letters. And when we balance chemical reactions, we are only allowed to change the coefficients. The other numbers that we find in a chemical reaction are the subscripts, and they are written at the bottom of the letters. These represent number of atoms in the elements or in the compound, and you are not allowed to change these when balancing a chemical reaction. So if we have a look at our word equation of hydrochloric acid and a magnesium oxide reacting to form magnesium chloride and water, hydrochloric acid and magnesium oxide are the reactants, and magnesium chloride and water are the products. Here we represent the word equation using the symbols from the periodic table. So hydrochloric acid is HCl, magnesium oxide is MgO, magnesium chloride is MgCl2, and water is H2O. Now if we have a look at this equation, we write down the letters of the elements of the reactants. So we have hydrogen, chlorine, magnesium, and oxygen. And we do the same for the products. We have hydrogen, chlorine, magnesium, and oxygen. And we want to see if this chemical equation is balanced. So if we have a look here, always start with the metal and see if the metal is balanced. So in this case, on the reactants we have 1 magnesium, and on the products we have 1 magnesium. So the metal is balanced. You then move on and have a look to see if there is a non-metal in the equation. So we have hydrogen, chlorine, and oxygen. But in the general hints to balancing equations, leave the oxygen and the hydrogen till last. So we'll focus on the chlorine. So in the reactants we have 1 chlorine atom, and in the products we have 2 chlorine atoms. So in order to balance the equation out, we need to add 2 more molecules of hydrochloric acid. So if we do that, we now have 2 molecules of chlorine as reactants and 2 molecules of chlorine as products. It also means we have 2 atoms of hydrogen and 2 atoms of hydrogen, which means our equation is now balanced. So to end off today's lesson, I would like you to write down 5 questions related to what you have learned today. And each question must start with a different word. So to help you along, you can use the words what, who, when, where, why, how, or you could even challenge yourself and you could write what would happen if. If there is anything you're unsure about in today's lesson and you have any questions that you are unable to find the answers to, please email your question to grade9@worksheetcloud.com. I would like to thank WorksheetCloud for bringing this lesson to you, and thanks to you grade 9s for listening to these lessons. Goodbye.